Hello, it's Bill again, and today we're going to look into intrinsic spin from holographic data compression. So we're going to start with particle A's cosmic holographic event horizon, formed by 10 to the 122 particles crossing A's horizon, encoding each crossing as a Planck area of relative gravitational energy for a total of 10 to the 122 Planck areas, forming a relative inverted black hole horizon 14 billion light years away. And here you can see the horizon formed by the Planck areas and black hole-like gravitation, 10 to the 122 of them. Each Planck area is 10 to the negative 70 meters. And you can see that here's particle A in the center of its universe, and at 5.6 billion light years away, the star is receding at 0.4 C. And here at 11.2 billion light years away, this one and this one, the star is receding at 0.8 C. Because A's space-time is projected by its cosmic horizon, there is a problem with data density. A Planck area can define a particle on the cosmic horizon for a total of 10 to the 122 particles, one for each Planck area holographic tile at 10 to the negative 70 meters. There are 10 to the 183 Planck volumes within this sphere of 10 to the 122 Planck areas. Nature cannot project the 10 to the 122 Planck area resolution into the volume of 10 to the 183 Planck voxels by a factor of 10 to the 61. So a voxel is a 3D pixel, and it would take 10 to the 61 cosmic horizons to be able to encode all of the Planck volumes inside. But nature has a solution. Nature solves the 10 to 61 resolution problem by inflating the minimum spin node voxel size to 10 to the negative 15 meters, which is in the size realm of protons and neutrons. Spin half-matter particles are projected by their cosmic horizons at a minimum size of 10 to the negative 15 meters. However, this creates another problem. Even though the voxel size increased, the Planck volumes within that structure still need to be managed, as there are 10 to the 61 Planck volumes in a holographic voxel. There still exists a resolution problem. So here we can see that this is particle A, and its voxel size is 10 to the negative 15 meters. You can kind of consider that space creates these voxels to be able to identify a particle in space. Because there are 10 to the 61 Planck volumes in that holographic voxel, nature spins the surface of the voxel so the time dilation and length contraction contract that entire region into one informational point. This intrinsic spin must occur around all axes because a measurement could occur on any axis. So the entire surface in all dimensions experiences this intrinsic spin. Then no matter what direction you measure from, that axis is condensed to one informational point. This allows the holographic voxel to be tied as a 1-bit data node to a given Planck area on the cosmic horizon so that each of the 10 to the 122 holographic voxels are mapped to each of the 10 to the 122 Planck areas of A's cosmic holographic horizon. This also provides a way for nature to show quantum many paths behavior as it evolves from the uncertainty from intrinsic spin compressing a region of space into an information bit. So here we can see that we have 10 to the 61 Planck volumes hiding in this holographic voxel. So nature is going to introduce intrinsic spin around every axis. So the time dilation and length contraction contract all these informational points into one point. So the cosmic horizon projects spin around all axes in all orientations at an energy level based on the radius of the system. The equation, EDOF, the energy in a constrained degree of freedom, captures this radius, space, spin, energy level accounting. And here it is right here. You have a photon whose wavelength, photon energy whose wavelength equals object radius divided by 137 to strip out charge to get only spin information, times a natural log pi squared over natural log 3. And this is for a radius-based emission and triangular fold. So this is the cost for nature to encode 1 bit of information in that volume. As a light speed signal on the surface rotating in all axes condenses that entire region of space into 1 bit of information. For a radius of 10 to the negative 15 meters, EDOF equates to 10 to the negative 12 joules. This is the least amount of energy nature can use to encode that region of space. Because remember, each one of these has 10 to the 61 Planck volumes, and Planck energy is 10 to the 9 joules per Planck volume. So that's an incredible amount of energy to be able to encode that. So nature just takes this larger region, spin around it, condenses it to one information point at the bargain rate of 10 to the negative 12 joules. So here's the intrinsic spin collapse proposal. When A and B entangle at T2, they form a relationship between the two particles. But the spin axis remains unconstrained as only one point for each particle has been defined. Any number of spin axes could exist at one point, but when particle C interacts with A, now a second reference point can be made for particle A, collapsing the intrinsic spin to a particular axis. Because all intrinsic spin axes rotate at the speed of light, the selection becomes apparently random, as there's no way to externally choose a given axis. The second measurement point, T3, forms a temporal and geometrical line so the spin axis and sign can be determined. The first point measured is the first reference, and the second point determines spin axis and direction. At this point, intrinsic spin has been resolved, quantum to classical transition has occurred, and the emergence of the answer erases the state for the next interaction. Intrinsic spin once again exists simultaneously at all axes in order to compress 10 to the 61 Planck volumes into one holographic voxel. So here at T1, we have no reference, so it's spinning in every different direction, either direction. But once we have that first measurement, A and B bump into each other, now we have a reference point. Now spin could be going this direction or this direction. It could be going any of these directions centered on this point. It's still many paths. It has not been resolved yet. But now once we get the second point, now we can draw a line from the first point to the second point, and there's our spin direction and sign. And this is my best idea on how the universe is able to compress holographic information to turn 10 to the 122 informational bits into 10 to the 122 holographic voxels. Thanks for watching. I have two playlists actually that have a lot of good information: how gravity emerges, dark energy, dark matter, what movement is, how general relativity and special relativity work in this model. And remember, gravity's for the masses. Have a great day.